board, ICs.
Understood. So let me explain you. See, so PLC is a simple hardware actually. It takes inputs. It has got a small processor or some complex processor, and whatever the inputs that are being taken, it processes with respect to the code that is in the memory, and it gives the output through output devices. Like there are few um, interfacing devices will be there. We need to know each and every component during this time. So what I would say is this cannot be learned in a single day. I'll give you a brief about what S7 1200 and S7 1500 are, and what a PLC is, and what a SCADA is. And as you already know, you have already worked on PLC and SCADA, so you might be aware of that. And what communication protocols are available in the market, and how is this PLC is communicating with the various IO devices, and what sort of IO devices are present in the industry. And then I will also share you brief about this Arduino,
Okay.
and how do we relate Arduino with a PLC? So how do you excel PLC with the help of Arduino? So fine. So 4 minutes is done already. And can you see my screen?
Yes, sir.
This is now itself. To be
One
honest,
second.
fine.
Yeah.
Yeah, please.
Yeah, I can see the screen.
Okay. To be honest, I've created this PPT just for you, and just 1 hour back. And you can also see Gemini notebook here. Is you can see here. So it is
Yes.
using notebook LM. So you have heard that S7 1200 and S7 1500 two PLCs. Before this, there were many PLCs in the market, wherein small boxes kind of hardware was available, where IO devices were very hard to connect and all. So now it has become very easy for everyone as the technology grows. So this is the first screen. This is there will be an operating system and user program which is nothing but Siemens related, and main body will be there, wherein the exact code will sit there. Not to focus on that is my intention. Can you see this now?
Yes.
Yeah. This is the language of logic. Can you see something? What sort of programming be used in developing a logic in PLC, sir? I say like this is ladder logic. Previously, we used to work with this logic only, ladder logic, and wherein these are this is normally open. This symbol is this symbol is normally closed. Wait a second.
Yeah, I just want to let you know that I have a grip on ladder logic.
Good, great. So,
but I'm not aware of structure control language, like how you write the program. Whereas coming to FPD, yeah, I am familiar with that. I mean, I'm familiar with LAD and FPD other than SCL.
yeah, that's good. So since you are mechatronics, you might be aware of all this. So SCL
Yes.
is the most advanced that we worked on, and even now you don't have to take any tension about how to write SCL because ChatGPT or Claude can help you in this
Okay.
in a better way actually. So can I turn off my camera?
Yeah, sure.
Fine. So no issue. So this is FBD, since you know, and or not gate gates will be there where you'll write the
Yes.
logic, and there will be further blocks will be there where complex blocks will be there in a functional block diagram, where the collection of all the inputs will give the single output, and that output will be carried to fed to another block, another similar block,
Mhm.
which is much similar to ladder logic, even it is. And SCL, this is Visual Basic code we used to write, and now we are writing in Python. Using Python also we can write this.
Okay.
This is very easy, a simple language. If you are using Python, it is a very simple English we can use, and we can write the code. And for that, we don't need to struggle. ChatGPT is helping in a better way.
Okay.
And um, right, yeah. Coming to, can you see like there are two PLCs are there on the screen. S7 1200 and S7 1500 is there. So
Yes.
S7 1200 is a localized equipment, usually localized in sense. Uh, can I know where you are working?
In a machine company.
Machine manufacturing company.
Yes. I mean,
Okay,
small product manufacturing companies. But I do work on CNC machines.
fine. Okay, so assume that I've got a single system. I've got a system where the springs will be manufactured there. Complete localized setup in about
Mhm.
a single room. There will be an input, and so all the inputs and outputs will not go away from that room. Everything is in that single room and are connected to a PLC. In such cases, this S7 1200 is very useful. Whereas S7 1500, you have got many rooms and many equipment in all the rooms, and wherein you wanted to look at the functioning of each and every equipment by sitting in a single room, then you should have a distributed control system, uh, which is S7 1500 will help on that. What it does is, it, can you see this is the main PLC, this is a main processor, and it
Mhm.
has got some display to work locally, and these are all IO devices. This will be given to each and every room. So from each and every room the data will be fed to the central processor, and from that processor we can visualize in one screen by using SCADA. So
Okay.
this is S7 1500 has got like many inputs it can take, and it is sort of a distributed control system, we can say. And S7 1200 is, it has limited number of IOs, so we cannot extend to many other rooms. Though we can extend to other rooms, the inputs and outputs are limited. So extending hardware is difficult for this, and connecting other IO modules is also like a hectic job for this one. Again, some interfacing devices are much needed. So S7 1200 is preferred for small machines where
Got it.
the capacity is already expected and it will not go beyond this. Like a small room having a small equipment. Consider having a consider like a cement plant. Go to a cement plant, and there are many huge area will be there, and there are many inputs and outputs coming from various locations. For this, we need a distributed control system. In such locations, a 7 1500 will be used. So here it is mentioned, best for standalone machines. Uh, we can expand this. So this is all about S7 1200 and S7 1500. Later, we will go through this um, Arduino and this IO structure also, communication structure. And this is
Got it.
yeah. And as I mentioned, for S7 1500, it is a high performance module, and it has got local display as well. So wherein you can check the inputs and outputs and error status, we can rectify immediately at the by standing near the PLC unit, DCS unit. And whereas
Okay.
S7-1200, we cannot work near the system. But if we have to work, then we have to procure another display module and add another interface module for display and connect there near to the S7-1200, which usually no one does, because since it is a smaller system, near to the PLC itself, there will be a SCADA. So people used to control or correct from SCADA itself, that particular PC. So these are basic features, S7-1200 and S7-1500. Working memory, like as I said, since there are a very less number of predefined number of IOs for S7-1200, so the memory will be very less. For S7-1500, it is very huge and it can be expandable. And the processing speed also, like 1 millisecond for 1,000 instructions for 1 millisecond. And we can see S7-1500 is very fast. That is what S7, since S7-1200 is for localized standalone equipment, all these spec are limited, whereas S7-1500, since it is a big, huge distributed control system, it has got a good spec. And that is what this is what is all about. And since S7-1500 has got a diagnostic screen there itself on the PLC unit, we can monitor any input there itself from a monitor and control, and we can troubleshoot also there. S7-1200 sorry, S7-1200 excels at stepper PTO control. This is all like, although here it is saying excels at a basic stepper or PTO control, but the processor will be the same, the logic will be the same. So PID controllers that are used, very recent PID controllers have got neural network logic within that, and we are not calling that as a PID controller, we are calling that a advanced controller. And these advanced controllers are present in S7-1500. Assume any thyristor module that control furnace. So if the temperature is reaching 1900 or some set point, then PID acts and reduce the output current to the furnace so that the temperature will remain constant. And in certain cases, what happens is the environment will be dynamic. So in certain cases, the furnace door will be opening and uh, closing will be happening. In such cases, to maintain this temperature consistently, a neural network logic has been developed and placed in certain controllers, particularly in S7-1500. So what they do is they look for the n number of times it has opened for n number of seconds, and it assumes, so if the door is kept in open condition for about 10 seconds, the temperature drop is this 30 degrees or whatever. So this is what is the data that I have collected from the equipment. So in case in future, if someone opens the door to maintain the temperature, the output should be adequate to maintain the temperature. So this is what is advanced controllers are doing now. S7-1200 has got a processor with good thinking capacity, but it doesn't have this neural networks kind of logic. So whereas S7-1500 is a good controller. So rest all programming part and all will be similar. You can use a ladder logic, a structured query language, or FBD. We can use any of the programming structures.
I mean, we can use any three of those program to function, right? So we don't need specifically you to use SCL or FPD.
Yeah, this one you're talking, right? So
Yeah.
we can use any one of these. Only thing is,
Okay.
when we purchase any when we purchase any PLC,
Mm-hmm.
we have to procure the software also to develop the to that is what to develop the logic. So
Okay.
here the software is not free of cost for PLC. Hardware is separate, and um, logic development, another software they will provide, semantic software or TIA portal. They have got many platforms, Siemens particularly, and
Mm-hmm.
in that we have to develop this logic. For during that development of the logic, we can choose the option either ladder logic, FPD, or SCL. And many other languages are also there. We can write a code directly, VB script. Other than this SCL, there is another way of providing the logic. So we only thing is we have to select there. We can do either the ways.
Okay.
Is this the question that you are asking?
Yes, yes.
Fine. And then see, basically, if you are working on any S7 1200 and
Mm-hmm.
you have S7 1500, you can make the both. You can make both the PLCs communicate each other with um, interface modules. So S7 1500 accepts any sort of input, but it has to be mentioned in a TIA portal in the sense semantic. Uh, I just now said that to develop any logic, we need a software. To build any logic, we need a software. So that software,
Yes.
when you select S7 1500 as a controller,
Mm-hmm.
then it has got many options. Even if you select this S7, like there will be many drop downs will be there. If you select S7 1200, obvious, and it instantly recognizes the data that is coming from S7 1200. But here the tricky part is S7 1500 is not doing all this activity, but the software is doing this activity. That is what. So software manage TIA portal for Siemens, it is doing the
Mm-hmm.
activity. But for S7 1200, this TIA portal has limited access for all these uh, act, for all these what you can say um, act, options.
Okay.
So this build the new S7 1500, I can configure. You can that is what whenever you wanted to configure n number of racks you can place for S7 1500 and export PLC tags. And I would like to say one thing
Mm-hmm.
um, for every input we will give one name. Let us call that name as tag. On the screen, SCADA screen or HMI screen, um,
Mm-hmm.
whatever the input that you give from the SCADA screen, that button, particularly button, in that button, if you are entering, like if you are clicking on and off, for that on button, there will be one tag. So in the back end, a tag name will be given for that button, and that button will be linked to the PLC IO device, IO tag. So this tagging will happen manually for S7 1200, but whereas for S7 1500 sort of advanced controls, advanced systems, this tagging happens automatically.
Okay.
That is what. It is very easy now whenever you use this S7 1500. It's like uh, universally it creates a set of tags. You only need to pull the tag or copy the tag and paste it at the IO port or in the SCADA. If you are defining in the SCADA for on button, you have to copy and paste the tag name directly. But for S7 1200, it is not in such a way. For each and every tag, you have to name the tag, and assign the tag for all the in all the locations. So this is like we can communicate n number of devices to S7 1500. Is this is we can call this as architecture, although it is not an architecture, but sort of an architecture where this is a 1500 PLC is there, and these are remote IO devices. As I said, all these devices will be connected to this using Profinet. They are saying Profinet. There are few communication protocols are there: Profibus, Profinet, Modbus, RJ45 series connections. Like a Profinet is used for this one, and Modbus is used in different locations, and Profinet is the most advanced, and Profibus is used for the devices VFD. From VFD, this is here. Can you see the motor here?
Yes.
Motor is controlled through a drive. So V90 is just an example. So so a motor is here, a component is here. This component is called variable frequency drive. What it does is it has got some thyristor circuit inside that. It gives the input to this motor. It gives the input to the motor. So if it is 230 volts, example I'm saying, if it is it could be 440 or let me explain you. 230 means 230 volts. If it gives 150 volts and it rotates in a 50 speed, 50% speed, or and if it is 200, so this current, whatever the voltage is there, the voltage control is happening here with the help of thyristor circuit that is present in this device. So for these devices, so for this VFDs, there won't be Profinet for all the times. Profinet it might not be preferred. During these cases, Profibus will be used, wherein this Profibus communication will be given to this nearby this IO module, and where this IO module converts this Profinet connection, Profibus connection, and transfers to this main PLC through Profinet connection. This is a tricky part of everywhere we face in the industry, where VFDs or few IO devices are be there, so they might not be having the same communication protocol that the main system is having. So in such cases, there will be additional IO interface circuit will be there. So that is the way these model numbers will vary. I said S7 1500, and again there will be suffix will be there, S52 or S52 model number will be there, and sub model will be there. That model says that it has got these many communication protocols. This might not be there for S7 1500, but for S7 1200 and lower versions, it is there. So wherein both the communication protocols will be there. So where we can use any one of them. If single communication protocol is there, then model number will change. All the model numbers are based on mainly particular to communication protocol only. Internally, the memory and processor will always be the same for most of the PLCs I'm talking. This is universal connectivity. This is Modbus, I said. Just now I have explained. Modbus, Profinet. Modbus is also a communication protocol wherein the older systems that is what legacy means. The older systems, they can only give the data in a series manner. So for every, if you have consider, if you have this particular devices, can you see my point?
Yes.
This sort of device. Okay. This okay. Assume this sort of devices are 10 here. 10. All these 10 have to communicate with this one, but all these 10 don't have this Profinet communication. So it has only got a Modbus. Modbus, what it does is a single cable will be laid in such a way. Yeah. Modbus is a single cable will be laid to all such devices, like 10 devices, and each device will be given an address, and this there will be an IO interface module will be there. Interface module, we will program about the number of devices connected and address. So for every millisecond, for each 1 millisecond or a tenth millisecond, the data from one particular device will be connected, and for that data, this address will be assigned and will be fed to our main PLC. So Modbus communication happens in this way, whereas Profinet is straight away, like using a different protocol. It data transfer will be in a huge manner with bulk. For bulk data, single address will be defined and will be transferred, and transfer rate is also very good for Profinet. As I said, for every 10th millisecond, or once for every 1 second, one device data will be collected using Modbus. Whereas for Profinet, for every, it will be 10 times bigger, like faster than this Modbus.
Okay.
Yeah. See, I kept going in my own way. If you are like, if you want me to stop at any point of time, you can stop me.
Yeah, sure, sure.
Yeah. So that was about, so far I told you about basic hardware of S7 1200, and 1500, and various IO modules that can be connected, and interfacing devices, and various communication protocols like Modbus, Profibus, Profinet, RJ45. So coming to this SCADA part, as I said, hardware is separate and software is separate. Particularly these companies, what they do is hardware. If you procure hardware, they won't give you the software. And in
Okay.
the software, there will be two kinds of software will be there. Like one is development, the other one is for usage. Usage in the sense, you develop the entire SCADA and place it in your location and use the SCADA screen. SCADA, for that SCADA, they will charge particular amount, and that software will be different. And for development, another software will be there. So wherein you have to put the license there again, and you can start developing. Developing in the sense, you can make changes with the SCADA. So, and even for logic development also, it has got a separate software. So total 3 softwares will be there to say. One is the ladder logic or FBD development software. The other one is SCADA, for SCADA development or production oriented. So both production oriented and development, both are same, except having a license. Like after placing a license, it becomes a development software. And the software, whatever they provide, is with respect to tags. Tags in the sense, just now I said, you have one SCADA, assume this is our SCADA, and here you have got one tank, and 4 tanks are there, and this is the motor. So now for this tank, we need to know tank level, and for this tank, we have to provide one tank name, and a few other sensors. Assume there are total 5 sensors are there for this one, and 5 here for 20, and for this motor another 2 sensors are required maybe. So total 22 IOs are there. For these 22 IOs, when coming to development of this SCADA, we have to give 22 tags, not just 22 tags. If it is a tank, if it is filling, if it keep filling, then the water level indicator we have to provide. So for that water level indicator, again, we have to give a tag and name it appropriately, and um, assign the IO. If it is tank level is 55%, it has to display till here. So like that level displacement, also that color changing, whatever the color changing of this particular area needs a tag. The tag is assigned to a level sensor. If the level sensor must be giving 4 to 20 milliamps. If it is giving 10 milliamps, that 10 milliamps is converted into, or in terms of percentage, 0 to 100%, and that 0 to 100% is placed in one tag, and that tag, if it is having 55%, and whatever the button is having one tag, this tag will go there, and if it is 55%, then it will show that is what, half of the tank as blue and rest as white. So now you might have understood, like, tags are being used for each and every um, option that is present on SCADA, that is dynamic. Dynamic in the sense that changes with respect to field values. Understood?
Yes, yes.
So the software will be sold with tags, tag, tags, 1 lakh tags or 1024 tags, or like that. They will sell the software for development. And after development, if it is production oriented, the if you remove the license, it becomes a production oriented, and that becomes a SCADA or HMI as you would like to use. And even the PLC is also for PLC ladder logic or logic development. We have only inputs and outputs, and there also we have few tags will be used. That tags also calculated during the software procurement. This TIA, Siemens have defined that total integrated automation software, where this previously we had for S7 200, S7 300, 215, 2DP, like that. Many models were there. For each and every model, we used to procure a separate software. Now, TIA portal, what it does is, it is an it is a huge, like, it is a bulk software that have all the internally predefined controllers will be there, wherein if you in the drop down, if you can select any one controller or one PLC that you have procured, so and so logic will be appeared on the screen. TIA portal is like integrated all the software that was available by the Siemens. And they have placed it in a single portal, that we can say. Now here you can see changing the tag address in the PLC logic instantly updates the WinCC. This is HMI panel. This is WinCC is a software name, and preventing the data inconsistencies. Previously, what this TIA portal, now if you use this TIA portal software, this is helping us in much better way. If we are changing the tag name in one particular location, suppose you say tank 1 is the tag name. If you are replacing it with instead of tank, you can some other name. That name reflection will happen in all the location where tank 1 is used. And there are many other
Okay,
options also where we can. It has become user friendly. That is what I would like to say.
good.
This is a redundancy. Redundancy is like for distributed control systems, for any plants that are operating 24/7. And if there is any problem with the single module, any module, and we have to turn it off and reset or any perform any upgrades, then we need a backup. We need an alternate similar sort of system. That is what is the redundancy system. Usually, most of the cement plants or critical units that works on 24/7, they keep these redundancy systems primary, they call it as primary and backup, and both will be given a particular address. And if we have to modify any primary module, any particular module, then we can upgrade this. We can keep this under maintenance for about 1 month or 2 months or 3 months, and during this period this backup CPU will keep running. And as soon as this is done, then we will take that into production environment, and this backup will also be updated in such a fashion. And in case if it is down, then immediately it switches to backup, and if it is down, it switches to this primary. So this is like having an inverter at home. Even for inverter, after power goes, it takes about 5 to 10 seconds to resume the power. But in this case, it is of no time, it is milliseconds, wherein you cannot, the equipment doesn't feel like something has gone wrong. Zero downtime is what is this? Synchronization, CPU sync code. That is whatever I have explained. This is Profinet IO HMI. This is if you have like you can if you can go through these points, you can understand easily.
Yeah.
The 7 1200 does not like 10. If you have 1024 or less number of IO points, then you can go with S7 1200. Basically, S7 1200 is for standalone equipment. And if you have n number of like 5 number of standalone equipment, then you can still use S7 1200 in all the locations. And having an extra IO interface module, you can connect all these to a single HMI. That option is available. But instead of that, you can use S7 1500. In S7 1500, this is infinite. Infinite in the sense that this is in terms of lakhs only. But even for as an like as you keep increasing the IO devices, there will be a load on the communication protocol. To improvise the communication protocol, again we have to place intermediate hardware to like establish good communication. That's all. This unified ecosystem wherein you can see this is a 7 1500 like that, and this is a 7 1200, S7 1200. This is S7 some other model. You can integrate all these models. That is what I said. If the communication protocols are different, but still we have got communication hardware where it converts the data from Modbus to Profibus or Profibus to Profinet. That options are available now. Like now we can integrate any sort of a machine, so PLC, to our SCADA system, and we can make a single ecosystem. And but before that, I wanted you to go through this like can like now the time is 4:42. Any doubts so far?
When I did understand briefly about the system, how it works, but in depth, yeah, I have to go through.
Since you are mechatronics, I would recommend you to work on this one now. This Arduino. Are you aware of this one? You were saying
Yes,
Raspberry.
yes. I am aware of this. Yes, yes.
Okay, then if you are aware, then this is very much similar to PLC.
Okay.
This is PLC, small PLC. It has got inputs, outputs. It has got a processor, and inbuilt memory will be there. and there is the communication protocol here and power supply unit. And we can also communicate this Arduino with other Arduinos also. It has got that feature as well here. So what I would recommend you is, this is about 500 to 600, and you can have this breadboard in 200 rupees, and you can perform basic operations on this one through this Arduino software. Arduino software will be like this. You can, it is user friendly and open source. It is, yeah, you can easily make any program using ChatGPT or
So
basic.
you want me to learn
Basic,
about Arduino first and then switch to uh, step
yeah,
7, right?
yeah,
Okay.
because you cannot have a PLC unit at home. If you can
Yes.
have PLC unit at office, you cannot work on that unless you have that software in your laptop license along with the license. But
Yeah,
once,
I don't have any license.
yeah, that is one. Even that hardware is also, you can find some like other ABB and all have some smaller piece PLCs that comes in 15,000 in the scale, and they can also provide the software. And if you can search in the internet, we can also find the licensed versions, although it is not appropriate to use, but licensed versions are still available, and you can put the logic. But at the end of the this complete activity, it will become of no use. It will be of no use. So it
Okay.
remains as a scrap in our house. That, but whereas this Arduino, it doesn't cost you much. Um, this can be used for this is similar to PLC, but whereas here we'll be using this Python language, C++ we'll be using. This is one code that developed ultrasonic test. This one. Um, can you see this code?
Yes, yes.
This
So we
code.
need to have on Python to work on Arduino programming, right?
No, no, no. See, Arduino takes C++
C++.
code,
Okay.
C++ code, and whereas Raspberry, it takes C++ as well as this Python code also. Even this C++,
Got it.
even this C++, you don't need to work completely on you don't need to put 100% efforts. Simple ChatGPT commands, you can get this code.
Got it.
Yeah. So I wanted you to work on Arduino first, and then understand about the logic, work on various codes, and have a number of many resources. See, one thing I would like to say, you can learn logic, how to develop the logics. You can learn about the software, but having that logical skill is very important. In your mind, you should have that uh, thought process, um, thoughts like develop a new logic using a single hardware. Like there is an LED here, and you can simply have a switch here, and you can if you click on the switch, the LED should glow. This is basic. Anyone can think about like this, but having the out of the box thought is very important. How to make this LED glow when you keep the switch at the door entrance of the door. Whenever someone enters into the a door, step into the door house, then they have to place the foot on their on some mat. That mat converts, that mat acts like a switch. That switch input will be given to this Arduino, and then further that Arduino gives the output to a light. So like that, out of the box thinking is very important.
Gotcha.
Despite of this learning nowadays learning about software, uh, particularly like S7 platform softwares, is very simple. It takes about, if you purchase the license, then you can go through that and we can work on that. But having while developing, someone asks you to, like, I've got this task in my company and I need this to be programmed in such a way, then people will struggle. People will have all the knowledge about the software, but they forget about the how to develop the logic. Developing the logic is important before we step into the um, any company. So developing logic comes with basic equipment when we work on. That is where I'm insisting you to learn Arduino and have identify many input output devices and work on these. And then similar thought process will be there when you work on PLCs or dish 7 1500 sort of DCS systems, where you know the logic and how to develop the logic. All you need to know is about
Mhm.
the software. About the software, if the version changes, everything changes.
Yes.
Even a skilled programmer developer will have to go for training purpose for about 15 days to gain the knowledge on the newer versions, later versions. So that happens everywhere. When that is where, like, I experienced, I initial days I worked on particular module and gained knowledge, and later on that disappeared somewhere, and I have to go through new modules and new software. That is where my experience is this. So having out of the box thinking is very much important than learning about any software. So
Gotcha.
that is what I would say. And this is 4:50 now. We have 10 more minutes. And for you, this is this is about this PPT is about various protocols, communication protocols. RJ45 is like this. And mm, this is what Profibus and point-to-point Modbus, RDOs, remote terminal units.
Hello.
Various communication protocols are there.
Yeah.
There's no insufficient time. Let's skip
Yeah,
this.
that's fine.
Uh, but uh, this is what is PLC and SCADA means, and about its software. And very basic version of PLC is Arduino, and SCADA version
Gotcha.
is Arduino software, which is open source, where you can write a code there itself and execute it and look at the output in the Arduino software. And we almost communicated 51 minutes. If you have any doubts or like any sort of question that you would like to ask, please.
Hello.
Yeah, ma'am.
Hello. Sir.
Yes, ma'am.
Yeah. Ram sir.
Yes, ma'am. Yes, ma'am. Please.
సార్ డెమో అయిపోయిన తర్వాత నాకు చెప్పండి, నేను స్టూడెంట్తో మాట్లాడాలి.
Fine. Demo అయిపోయింది. I'm taking like certain questions during this session,
ఓకే.
if you have any.
I mean, I don't have any questions, but yeah, I need to go through Arduino and then yeah, we'll get back to you if I have any
Fine.
doubt.
Yeah, Suraj. Mm, yeah.
Yeah, and
Can I ask you a few questions?
yes,
Like
yes, sir.
what is your experience?
Uh, for the learning I got now.
No, 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 no. Since you are working somewhere, then
Uh-huh.
since when are you working?
So the thing is, I'm working in a machine shop. So basically, I'm a quality engineer, and then I did work on machines as well as quality. So I manage both, basically as a manufacturing engineer.
Okay,
And then I do work in night shift, which is basically 10 p.m. to morning 6 a.m. So I'll be
okay,
home by 7 o'clock.
okay. Married or what?
So no, I am single.
Fine. So where did you complete your mechatronics MTech?
From Manipal University, Jaipur.
Okay. Good. And where do you stay?
Right now,
Yeah.
it's in Cleveland, Ohio.
City name?
Cleveland, and state is Ohio.
Oh, okay. Fine. So that is what. So good that you are into mechatronics and would like to explore uh, machinery
So,
and
so let's say, you mentioned that it's like 3 months course. So, what all I'll be learning in this 3 months? So, may I know that?
yeah, it is 3 months because every day class is, if it is 1 hour, it is 2 months. If we have weekly once or twice, then it goes 3 months. Uh, since my screen is in sharing, this is already I completed a course uh, for one batch. This is 26 sessions will be there. Each session is about 3 to 4 hours, and
Okay.
3 to 4 hours. And during this session, um, explaining about this, this is developed for school kids, not for graduates like you. It is just a 15 days course for you. This you can learn all this in 15 days. Please excuse me.
Okay.
Hello. I'm call on. Yes. Yeah. This is for school kids, and
Okay.
wherein I have also taught them about um, how to use Sudoku, how to work on Sudoku and all. This is I have developed a this uh, app. I've developed an app. This is an app actually. Apps data. This is. I gave them an app where everyday class they will be looking into the class data, and they will, like, for that particular data, particular questions will be there. They will be answering those questions, and Sudoku, loop the loop circuit. Three games are provided for them from basic level. And while coming
Got
to
it.
this is 26-day program, and this was my schedule actually. Daily Sudoku time, and this is from 9 to 12:30. There were few breaks, warm-up activities and fun activities were there. But the core concept was taught for about 2 hours in every day. Since they were like school going kids, they don't know about the current voltage concepts.
Okay.
I started from voltage on explaining about that. I've also taught them like how the basic computer works, like back end of code, what the system will be looking at the code. Like it looks at in a binary way, binary zeros and ones. So this is 30-day,
Got it.
all the 26 days program. And finally, when it comes to the day 24, AI powered coding and using AI tools for robotics. Here we
Oh,
have, so I taught them like how to write the code using AI. So using chat